Yes, good day, my good fans out there. I am Dr. T.I.U., your chemistry lecturer on social media. Our last lecture, we dealt on Dalton's law of partial pressure. The law states that when two or more gases, or even three gases, which cannot chemically react together, are put in a container, the sum of the pressure or the total pressure of the gases in the container will be the addition of the partial pressures exerted by the individual gases. So now I want to use a simple analogy to explain Dalton's law of partial pressures. See on the board here. Simple analogy of Dalton's law of partial pressure. Look at these containers you are seeing. Let's say this is container A, container B, container C, container D. Now, container A is occupied by nitrogen 4 oxide gas. Container B is being occupied by carbon 4 oxide gas. Then container C is occupied by nitrogen gas. And container D is occupied by chlorine gas. These are individual gases. Now, assuming the temperature they are now is 45 degrees Celsius, assuming that they are now in these containers at this prevailing temperature of 45 degrees Celsius. The law is now telling us that at this temperature, the collision of the molecules of all these gases in their individual containers will be the same. If it was taking maybe 2 seconds for two molecules to collide, it will take the same 2 seconds for two molecules to collide. It will take the same 2 seconds for two molecules to collide. It will still take the same 2 seconds for two molecules to collide. That's what he's talking about. That is what the kinetic theory is saying, that at the same temperature, the gas pressure of the individual ones will be the same. That is, the average kinetic energy will be the same. Now, here, the pressure that will be exerted by the molecules here cannot be the same with the pressure of the molecules that are exerted in this. Likewise, the molecules here, the pressure they will exert will not be the same with the pressure the molecules they will exert. The same thing applies to here. Because the pressure is as a result of what? The frequency of the collisions of the molecules in the container among themselves and against the wall of the container. So, in just the case now, if you want to calculate the total pressure of these 4 gases now, it means you will find out the pressure of the gas here, add it to the pressure of the gas here, add to the pressure of the gas here, and add to the pressure of the gas here. That's what you will do. Now, that's what it's not saying. Instead of being in the same, in different containers, they are now put in the same one container. One container. One container. Instead of individual containers, the 4 of them are here now. Now, these lines you are seeing is used to demarcate that the molecules of nitrogen 4 oxide cannot mix with the molecules of carbon 4 oxide gases. The molecules of carbon 4 oxide cannot mix with the molecules of nitrogen. Likewise, the molecules of nitrogen gas cannot mix with the molecules of chlorine gas. Though they are in the same container, they are not chemically mixed together. So they cannot move beyond the boundaries. Here, the molecules here within this range will collide among themselves and against the container wall. Here also, they will collide among themselves against the container wall. So also all these ones. But the molecules here will not come here to collide. The molecules here will not come here to collide, neither here to collide. So though they are just in the same container, but everybody is just exhibiting pressure individually without mixing with the other one. And that is why a chemical reaction cannot take place except the molecules of the two will mix, because there will be a breakage of bond and bond rearrangement, otherwise it won't take place. So if you want to find the pressure, the total pressure of all the gases in this container, do not mean that the partial, because the total pressure here now will be the partial pressure of each of them. So the total pressure here will be now the partial pressure of nitrogen dioxide plus partial pressure of carbon dioxide gas plus partial pressure of nitrogen gas plus partial pressure of what? Chlorine gas. That's why the formula comes like this. Pressure total is equal to partial pressure of A, partial pressure of B, partial pressure of C, partial pressure of D, and in that order. See, because it is the partial pressure of each of them that constitutes the total pressure. Now look at this example I give here. 2 moles of carbon dioxide reacting with oxygen to form what? Carbon dioxide. Here tells you that the molecules of carbon dioxide and oxygen can mix. They can mix. So the total pressure will be based on the total pressure of the container. Look at it here. If this is the container and the two gases are already here, so the molecules are colliding. You cannot differentiate the molecules of oxygen from that of what? Carbon dioxide. So the mixture of it gives you carbon dioxide gas. So in this case, if you're looking for the total pressure, it is easy to find because already the two of them are mixable. So that's why we are saying that in Dalton's law of partial pressure, the gases are not mixable. They are not coming together to form a chemical compound. So therefore, the total pressure will be determined by adding the individual pressures they are contributing, which we call now the partial pressure. You add all together. That will give you the total pressure of the gas. So this is a simple analogy of Dalton's law of partial pressures. So please comment, like it. Please share this video and remember to follow me and then also subscribe to my YouTube channel. Thank you.